Now let's see, let's assume that we are using variable partitioning, okay? We are using RAM and we are using variable partitioning. As of now, this is how RAM is looking like, okay? Initially our operating systems came into the RAM, then some process came into the RAM and it left the RAM. Again P1 came into the RAM and some other process came into the RAM and again it left the RAM. Only in that case holes will be formed, okay? These are the holes. Holes are vacant spaces, okay? Now we can actually, now once a new process is coming from hard disk, okay, whenever a new process comes into from the hard disk, we need to allocate it inside the RAM by finding a hole which is big enough to hold the process, okay? See, we need to find out holes which can completely accommodate this process, okay? In case if the size of the process is say 10 MB, then the size of the hole should be bigger than 10 MB in order to accommodate that process, okay? That is what we will be doing. Now there is a high chance that more than one hole can actually accommodate a process, right? For example, here let us assume all these are bytes, okay? From 100 to 200 we have 100 bytes. Similarly, from 220 to 320 there are again 100 bytes, okay? Now whenever a new process say 80 bytes or 90 bytes come into the RAM or 100 bytes come into the RAM, I can either accommodate over here or I can accommodate over here. So there are more than one chance, more than one possibility for accommodating our process inside the RAM, okay? Now among these various possibilities, how can we decide a single hole, okay? For that we use these algorithms, okay? For this we use the algorithms. See, first point is we are only taking the holes which are actually big enough to hold the processes. In case if the size of the hole is less than the size of the process, then definitely we cannot accommodate our process inside that hole. That's for sure. Now, in case if we have more than one hole which is big enough to hold our process, now then we need to decide one among the various possibilities, okay? For that we use this 4 algorithms, okay? Now what first bit says is, you keep on traversing the RAM. Now how will we find out which are the holes? We have already seen it, okay? It is nothing but linked list. We will be traversing the linked list, and then once we find out the hole which is big enough to hold the process, we will note the address and then we will go to that address directly and then we will place the process, okay? So just to find out the holes, we are going to use the doubly linked list, okay? We have already seen it. Doubly linked list or bitmap, anything is fine. So this is the only reason we use it, okay? Now we can even actually, while solving problems, we don't even need to see this. We can even see this and solve the problems, right? See, now whenever I'm seeing, for example, a new process comes into the RAM, in case of first bit, what I will do is, I will keep traversing the RAM from the beginning, and whenever I find a hole which is big enough to hold the process, I will immediately accommodate that process, okay? That is what first bit means. Now once the first process is done, let us assume a new process comes into the RAM. Now again what should I do? Again I should need to start traversing the memory from the beginning, and whenever I find a hole which is big enough to hold the process, again I will accommodate the process. This process will keep on continuing as the new processes come from hard disk into RAM. Okay, that is what we mean by first fit algorithm. Now next fit is almost the same. See, coming to first fit, we have one advantage. What is an advantage is, in the best case, okay, in the worst case, we might have to traverse the entire linked list, or we might have to traverse the entire address space, right? In the worst case, which means I might find the hole at the very end of the RAM. But in the best case, what might happen is, immediately I might be able to find out the hole, and so this traversing time is actually getting saved, okay? So in the best case, I don't need to traverse the entire RAM, but I will be able to get it in some constant time. Within some time itself, I will be able to find out the space which is big enough to hold our process. So that is one advantage of first fit. Okay. Now, apart from this, do we have any other advantages? Okay, that is the only advantage. We'll see it. We have one more advantage. We'll see it. Okay, later. Now next algorithm is nothing but next fit. Now what next fit is almost similar to first fit, which means initially we will start off traversing the address space. Once we find out a hole which is big enough to hold our process, we will accommodate our process. It is exactly like first fit. Now once accommodation of a process is done, once a new process comes into the RAM, what we do is, we don't start off from the beginning, rather we start off from the address where we left out. by traversing the RAM in order to find out the hole which is big enough to hold the process. Okay, see, let us assume our process has been accommodated at this space. Okay, now what we do is we will not start from the beginning for the next process. We will start from here and then we will traverse it. If you are not able to find out the hole over here, we'll again start from the beginning. Okay, that is the only difference between next fit and first fit. Okay, apart from that, they don't have much of a difference. Again, even in next fit, there is a high chance that we don't need to traverse the entire RAM. Rather, after traversing for some time, either we are starting from the beginning or we are starting from the place where we accommodated last time. Only after traversing for very few amount of time, we might be, okay, I'm not saying we will be, we might be able to find out a hole which is big enough to hold the process. So in the best case, see, in the worst case, we might have to traverse the complete address space. That's for sure. But in the best case, we might end up searching for very less time and we'll be able to find out the hole. Okay, that is an advantage which is there for both first fit as well as best fit. Okay. Now, first fit as well as next fit, okay? We didn't see best fit till now. Now, what is meant by best fit is you need to traverse the entire address space, okay? Definitely, you need to traverse the entire address space in order to find out the holes. Now, once you find out the holes, we might be able to find more than one hole, right? You know that, which is big enough to hold our process. Now, among these holes, we will take the smallest hole and then we will accommodate the process, okay? Let us assume 3 holes are possible inside our RAM which is big enough to hold our process. Okay. Now, among these 3 holes, we will take the hole with the smallest size. Okay. In case if there are 3 holes, say 5 MB, 10 MB and 15 MB, then we will choose 5 MB because 5 is less than 10 and 15. So, we will pick the smallest hole and then we will accommodate the process. Now, the disadvantage with best fit is, see, actually all 4 are very good algorithms. We can't say that one is better, one is worse, but definitely best fit has one disadvantage comparing to first fit and next fit. In the best case, coming to first fit and next fit, we need not traverse the complete address space, right? But that is not the case. That is not the case coming to best fit. Coming to best fit, we need to definitely traverse the complete address space in order to understand which is the smallest hole, right? See, in order to find out the smallest hole which is big enough to hold the process, we need to find out all the holes which are there, right? In order to find all the holes, you might have to traverse the complete RAM, right? That is one disadvantage coming to best fit. Now, there is one more disadvantage coming to best fit. What might happen is, let us assume there is a very small hole, okay? Now, let us assume this hole is good enough or good enough to hold our process, okay? Big enough to hold our process. Now, what we will do is, we will accommodate the process over here, okay? Let us assume we have accommodated this process over here. Now, this is again a hole, right? Now, what we have done is, the hole was already smaller, we made it even more smaller, okay? We made it very, very, very small. Now, because of this, the disadvantage is that there might be very less chance that our process is of size, this less size, okay? Our process is of this small. That, see, a process will generally will have some size, some range, right? This size should be somewhere greater than this. See, there can be a possibility, of course, for a very small process, but we mostly get processes of size, say roughly around greater than 2 MB. Okay, let us assume, just for an approximation, let us assume all processes will at least be of size 2 MB. Now, in case if we get a hole which is less than 2 MB, what will happen? This hole will remain as it is, because we will not be able to hold any process. Okay. So we are actually not utilizing this space. Okay. So we are actually wasting this space. This is another disadvantage of best fit. So what is this disadvantage is, best fit can make a smaller hole even more smaller, thus making that space as useless, okay? Because a process we might not be able to accommodate a process within that hole because it is very small, okay? So there are 2 disadvantages of best fit comparing to these 2 algorithms. Now coming to worst fit, what we do is, see, again worst fit has one disadvantage. What we do is, see, how worst fit algorithm works is, we will definitely traverse the entire address space, okay? We will definitely traverse the entire address space and then we will find out the largest hole which is big enough to hold our process, okay? There might be more than one holes, which is big enough to hold our process, out of which we will choose the hole which is largest in size, okay? Now coming to this algorithm, again this suffers from the disadvantage that even in the best case, we might have to traverse the complete address space or complete RAM in order to find out the largest hole, right? Which is not the case coming to these two algorithms. So even in the best case, we might have to traverse the complete address space. That is one disadvantage. But this disadvantage, second disadvantage of best fit has been overcome, which means we will not make the smaller hole even more smaller. Okay, that will happen only in case of best fit. That will not happen in case of worst fit. Okay, so these are the simplest algorithms. Now you might ask me a question: out of these four algorithms, which is the best algorithm and which is the worst algorithm? Okay, you might ask. See, it really depends on what is the order in which processes arrive. Okay, what is the order in which processes arrive? See, sometimes there might be a case where we will not be able to accommodate our process. For example, here you take the size of the largest hole is 200 MB, right? Now, in case if a process whose size is greater than 200 MB comes into the RAM, we will not be able to accommodate that process, right? We will not be able to accommodate that process. But we wanted to accommodate as many processes as possible inside our RAM. Okay, so based on which we can say an algorithm is very good or algorithm is very bad, right? In case if an algorithm is able to accommodate more processes, we say that is a better algorithm. Whereas in case if some algorithm we are using and we are not able to accommodate a process, we say that this algorithm is not very good, right? That is how we evaluate the algorithm. Okay, depending on how many processes it can accommodate. Now, based on that criteria, which among these four is the best algorithm? You might ask me a question, right? But the answer, there is no defined answer for that question. It really depends on what order the processes arrive. Okay. Now, in case we will solve some problems, okay, you will get it even more clearly. Okay. And the last point, in case if you didn't understand it clearly, fine. Let's see it some problems. You will be able to understand it. Okay. Fine.